Okay, so in this one, we're going to go for example 1.2. So the question is, given f dash of x equals 3x add 5, find f of x. Okay, so same again as the previous video, we need to integrate 3x plus 5. Now, it's a bit different because we have this like function notation now, don't we? So just a quick recap, and maybe we'll fill in some gaps if you weren't sure about this. So if you have a function y, so let's say, x cubed, okay? If you differentiate it, you get dy dx, okay? Dy dx is the so-called gradient function of x cubed, and it would be 3x squared. An equivalent way of writing this, an equivalent notation, is using function notation. So instead of writing y, I'll just write f of x. So f of x equals x cubed. And if I differentiate that, well, instead of writing dy dx, we have to write f with a dash, so f dash of x, and that would also be 3x squared. So these are equivalent ways of writing it. So dy dx is equivalent to f dash of x, y is equivalent to f of x. And, often in like exam questions, you will see like things like the curve y equals f of x is shown, and that's because they are equivalent. Okay, so we know it's integration because it starts off with an f dash of x, and we've been asked to find f of x. If the question was subtly different and it said, given f of x equals this, and then find f dash of x, then it would be a differentiation question. So I'm of the opinion that you've got to really pay close attention to detail, and that will help you spot the correct strategy to use. Okay, so we need to integrate it. So the way I'm going to set it out is I'm going to write f of x equals, and I'm going to write 3x, but I'm going to have to add 1 to the power, aren't I? So x currently is to the power 1, so now it's going to be to the power 2. Then I'm going to divide by that new power. And then for 5, well, as we had in the previous video, so constants, when you integrate them, you stick an x on them. And then finally you need a plus c. So we're going to talk about why in a later video, why we need a constant, but whenever we integrate, we need this plus c at the end. If you're still a bit unsure about why 5 goes to 5x, okay, here's a couple of reasons. So 5 we can think of as 5x to the 0, and then if I apply the rule we've just been doing, add 1 to the power, divide by the new power, 5 over 1 is 5, x to the power 1 is x, so 5x. So hopefully that will convince you that it will go to that. Another way you can think about it is, now that I've integrated 3x plus 5 to 3x squared over 2 plus 5x plus c, this result has to now differentiate back to that. It's a bit like when you factorize a quadratic, for example, into a double bracket. You expand it out to make sure it's correct, right? You can check by expanding. So in this case, whenever we integrate, we can check it's correct by differentiating it back. And if I do differentiate it back, well, 5x, you can think of 5x as 5x to the 1, bring the power to the front, 5 times 1, reduce the power by 1, so subtract 1 from the power, 5x to the 0, and that is the same as 5. Okay, so hopefully that convinces you of why that is the case, and this is the final answer to this question.